Lunar recession and the age of the Earth. One area of geophysics that gets little attention for its degree of importance is the recession of the Moon. Yes, the Moon is slowly moving further away from the Earth, and it is slowing the Earth's rotation in the process. This was first discovered following the Apollo moon landings by bouncing lasers off of reflectors left behind by the astronauts. The reflectors were designed to accurately measure the Earth-Moon distance. The measurements showed that the Moon is getting further away at a rate of 1.5 inches or 3.82 centimeters per year. Furthermore, a day is getting longer by 1.7 milliseconds per day per century. Both effects are a result of tidal forces between the Earth and the Moon, and these are the same forces that are responsible for the high and low tides experienced twice a day. Lunar recession has been used as evidence against the old Earth model for several decades now. Those supporting an old Earth have made an effort to respond to these calculations. Some have been a challenge, while others have been pathetic. The pathetic efforts generally involve projecting current rates back in a linear fashion, with no regard to the actual forces involved. This naturally fails because gravity is not linear. More challenging efforts involve complex calculations involving the effect of continental positions on the tides. What follows is the result of an objective study on whether or not lunar recession is a limiting factor on the age of the Earth, and whether or not it is compatible with the claim that the Earth is 4.5 billion years old. One way in which this study is different from most previous ones is that it only considers the forces acting on the two bodies. Most other studies simplify the calculations by assuming that angular momentum is conserved in the Earth-Moon system. This study considers the possibility that some angular momentum could be lost from the Earth by other means, such as frictional heating or other factors. The results show exactly what it would take for lunar recession to have been going on for 4.5 billion years, as well as whether or not it agrees with other data. There are several limiting factors on the Earth-Moon system. The first is theta being greater than 1/2 pi. If theta is greater than 1/2 pi, then the Earth's rotation would accelerate, and it would never drop below or even reach theta equals 1/2 pi. With theta less than 1/2 pi, then the Earth's rotation slows, and it can never get above or even reach theta equals 1/2 pi. The Earth's rotational velocity must be less than orbital velocity of about 4.5 miles per second. That's a rotation period of 1.5 hours. If the Earth's surface rotational velocity were greater than or equal to orbital velocity, then it could not form by collapse by natural movement. Furthermore, if the Earth's surface rotational velocity were greater than orbital velocity, then the outward stress on the planet would eventually tear it apart. The Moon's orbital radius must be greater than the Earth's Roche limit for the Moon, which is 9,496 kilometers. If the Moon's orbital radius were less than the Roche limit, then the Moon would be torn apart, nor could it have formed within the Roche limit. As a result, its orbital radius had to have been more than the Roche limit. The Moon's orbital radius at time t must be greater than geostationary orbital radius at time t. If the Moon's orbital radius were less than geostationary orbital radius, then it would spiral inward towards the Earth and not away from it. If the Moon's orbital radius were equal to geostationary orbital radius, then the Earth and Moon would be tidally locked and no change would occur. Note that with a faster rotation rate, the geostationary orbital radius would be smaller and could, at some time in the past, be less than the Roche limit. The following section shows 4 backward projections of lunar recession data based on 4 different conditions. The first is a straightforward backward projection with no tweaks. The other projections were made to deal with common mistakes made on the issue. Sometimes these mistakes are made by accident, but other times they are made to hide problems this data makes for a 4.5 billion-year-old Earth. This is a straightforward backward projection of the relative proper secular braking of the Earth's rotation in lunar recession data made without any tweaks. The current data is simply plugged into the math. The result is that the Moon would have been at the Earth's Roche limit of 15,562 kilometers 1.171 billion years ago. This is far short of the 4.5 billion years commonly given for the age of the Earth. This suggests that the Earth-Moon system cannot be anywhere near 4.5 billion years old. These results are similar to other calculations done by others showing that these calculations are valid. This is a backwards projection of the relative proper secular braking of the Earth's rotation in lunar recession data, made assuming the current relative proper secular acceleration of the Earth's rotation is constant. The relative proper acceleration is the difference between the relative proper secular braking and the observed net braking of the Earth's rotation. The reason given for the difference is the process of the Earth rounding out following the Ice Age. Once again, the current data is simply plugged into the math. The result is that the Moon would have been locked in geosynchronous orbit around the Earth 1.36 billion years ago. This is far short of the 4.5 billion years commonly given for the age of the Earth, suggesting that the Earth-Moon system cannot be anywhere near 4.5 billion years old. This is a backwards projection of the number of days in a year in lunar recession data, made assuming a constant braking of the Earth's rotation. This is not a reasonable assumption, but it is a common mistake. The result is that the Moon would have been locked in geosynchronous orbit around the Earth 1.36 billion years ago. So even this extremely generous assumption produces a result that is far short of the 4.5 billion years commonly given for the age of the Earth. This suggests that the Earth-Moon system cannot be anywhere near 4.5 billion years old. This is a backwards projection of the number of days in a year in lunar recession data, made assuming the Earth's rotation is constant. Now, this is not a reasonable assumption. In fact, it is totally contrary to observation. The result is that the Moon would have been locked in geosynchronous orbit around the Earth 1.55 billion years ago at 42,164 kilometers. So even this extremely generous assumption produces a result that is far short of the 4.5 billion years commonly given for the age of the Earth. These backward positions show that the forces on the Moon are far more important than those on the Earth in determining the maximum age for the Earth-Moon system. The fact that we do not even get halfway to 4.5 billion years, even when keeping the Earth's rotation rate constant, is strong evidence for the Earth-Moon system not being anywhere near 4.5 billion years old. We could potentially stop here, but several arguments have been raised against such conclusions, and we need to deal with those arguments. Old Earth proponents often point to paleontological data as evidence that the previous backward projections are wrong. The claim will often include a few examples that are often dated as millions of years apart. However, this claim does not consider all of the facts about this data, including alternative interpretations that do not have anything to do with lunar recession and the length of an Earth day. This paleontological data comes in the form of fossil bivalves and coral, fossil stromatolites, and fossil tidal rhythmites. Bivalves and coral are animals that tend to live about a year and show daily growth rings on their hard exteriors. Stromatolites are produced by the activity of cyanobacteria. Tidal rhythmites are produced by tidal action. Stromatolites are produced by the activity of cyanobacteria, and living colonies produce 365 layers in a year. Fossil colonies have been found with 450 to 800 layers in apparent agreement with the slowing of the Earth's rotation through the geologic ages. The main problem is that fossil stromatolites may not have formed from cyanobacteria. Some contain no evidence of the cyanobacteria, and carbonate precipitation can result in some very stromatolite-like structures, rendering the number of layers meaningless. However, even if there are legitimate fossil stromatolites, it could just mean that the colonies lived longer than a year in the past. When rhythmites are produced by tidal action, so-called fossil tidal rhythmites are assumed to indicate the Moon's position in the number of days in a month or year in the past. Now, getting data out of rock tides is not a simple process. It is based on the fact that there are 2 high tides in a day and that it changes every month from different positions of the Moon. Figuring out the number of days in a month or year in the past requires comparing patterns in the rocks for patterns expected to be produced by the Moon. The main problem with this is that it requires making assumptions about where the Moon was at the time, resulting in a degree of circular reasoning. In addition, there are factors that distort tidal rhythmites that can produce erroneous patterns. There is also an additional problem since the same types of patterns occur in varves. The question is whether or not these are rhythmites or barbs. It turns out that even experts have a hard time telling them apart in the geologic record. If they are varves, then the patterns are meaningless for determining past lunar position or the number of days in a year. Coral and bivalves normally produce one growth ring per day. Normally, it is 365. Due to the slowing of Earth's rotation, coral would have had more rings in the past on an old Earth. Fossil coral and bivalves have been found with 357 to 450 growth rings. The extra growth rings are assumed to indicate more days per year. However, they could mean that these corals and bivalves live for more than a year. Furthermore, in some cases what are being examined are monthly growth rings with the number of days in a year being calculated based on an assumption of more than 12 shorter lunar months. In those cases, it is assuming that both days and lunar months were shorter, making it circular reasoning to use it as evidence for the same. Stromatolites, fossil tidal rhythmites, and fossil bivalves and coral all have indicators interpreted as showing more days in a year in the past. However, when one looks closely at this data, the claim is shown not to be so certain. The first clue is the fact that the degree of scattering in the data is not what would be expected if it were really the result of lunar recession. It should produce a clear curve like is seen above, but it does not. Now scattering often occurs in data, but in this case, there is no reason for this degree of scattering. If there were a clearer line with a little scattering, the scattering could be early deaths. However, the actual degree of scattering does not indicate this. From a creation science perspective, the scattering of the fossil bivalves and coral, orange, could easily be a result of hydrological sorting during the Genesis flood, since those with more growth rings would be larger and thereby end up buried lower, and the scattering result from hydrological sorting being an imperfect process. The stromatolite data shows 4 pairs of data points. Though older, 2 pairs could be pre-flood and may even have been formed during the creation week. The other 2 pairs seem to be an early flood deposit. The relationship within each pair shows no trend. However, there is a trend among the pairs, and in particular among the 3 older pairs. This could simply represent a change in precipitation patterns. The basic assumption of this data that makes it meaningful to lunar recession is the dates. If the dates are wrong, and these fossils and features were a result of the Genesis flood or a recent creation, then it would not be expected to fit a lunar recession model consistent with a 4.5 billion-year-old Earth. From an old Earth perspective, this data represents real data on the slowing of the Earth's rotation. Thus, any viable old Earth model needs to fit with this data. If the old Earth model does not fit this paleontological data, it is a failed model. Naturally, old Earth proponents have tried to defend it from the laws of physics. Most responses to the lunar recession issue found on anti-creationist websites are little more than copy and paste jobs from a main anti-creationist website. One argument used to save the old Earth model is that continental location affects tidal drag. While this is true, since the closer the moon, the stronger its pull on the Earth, the rate of change tends to get very large. The result is that to save the old Earth model, it becomes necessary to virtually eliminate the effect of the continents. Eugene Poliakow's paper, Numerical Modeling of the Paleotidal Evolution of the Earth-Moon System, is an effort to calculate the effect continental movement-based actual estimates of past continental movement. Because of limitations of the methods used to estimate past continental movement, it only projects back 600 million years, but this is enough to evaluate the results. This is a chart showing the results of this study. You have the number of years into the past, the change in the distance of the moon, and the change in the length of the Earth's day. The way to judge the validity of a mathematical model is to see how well it reproduces known data. Poliakow's calculations give a figure of 2.91 centimeters per year as the moon's current recession rate, and 1.59 seconds per year per century as the rate of slowing of the Earth's rotation. The problem with these figures is that they both differ significantly from the values actually observed. The moon's recession current rate has actually been measured at 3.82 centimeters per year, which is nearly a third larger than Paleontological's model indicates. Furthermore, the slowing of Earth's rotation has been measured at 0.8812 seconds per year per century, which is just 55% of what Paleontological's model indicates. At first glance, the fact that Paleontological's model overestimates the deceleration rate of Earth's rotation would seem to be a plus, but the limiting factor of the age of the Earth-Moon system is the position of the Moon, not the Earth rotation rate. Since the Moon's recession rate is actually higher than in Paleontological's model, the error would be a clear negative. The real problem is the differences between the model and real-world data shows there to be a fundamental flaw in the model. It means that Paleontological overlooked one or more major factors that could easily nullify his results. The final flaw in this model is that it does not produce results consistent with paleontological evidence. Any old Earth model for the evolution of the Earth-Moon system would have to agree with both present system data and paleontological evidence, but Paleontological's model disagrees with both. The main argument is based on the notion that in the past, the phase angle between Earth's lunar tidal bowl and the Moon was smaller than the current 3 degrees. In the abstract of his paper, Hansen states that past calculations leading to 1 to 2 billion years maximum age for the Earth-Moon system assume a constant frictional phase lag angle. To reduce the phase angle, he claims that the current continental position has produced an unusually high phase angle. He further proposed that when there was a single supercontinent, the phase angle was smaller than today. However, other calculations do not assume a constant phase angle, showing that the phase angle is a function of the rotation rate of the Earth and the orbital rate of the Moon. The result is a tendency of it to be higher in the past, unless the Moon is near geosynchronous orbit. The conclusion given is that the Moon started at a distance of 151,000 miles with a 12-hour day on Earth, though often the 12-hour day is omitted. However, when this claim is studied more closely, it does not work without specific tweaking to get the current Earth-Moon system from the starting conditions. A preliminary backwards calculation shows that a phase angle of less than 1 degree is needed for most of the Earth's history for the Earth-Moon system to be 4.5 billion years old. In this backwards calculation, no geographic basis is used to get the 1 degree phase angle. It is just what is mathematically necessary to save the 4.5 billion year figure from the laws of physics. In this case, a 1 degree phase angle was used to project the number of days in a year backwards. When compared with old Earth paleontological data, it falls far short of that data. It shows that such a slow slowing of the Earth's rotation is not workable. Simply put, it does not agree with other data that it must agree with to be correct. Now, when the starting conditions of this claim are put into the math, along with a phase angle that would result in today's lunar distance, the number of hours in a day at present comes to 26.44 hours. This is above the present-day value of 24 hours. It produces a number of days in a year that is totally below the paleontological data. This is so bad that it even goes below a fossil indicating just 350 days. In an effort to be as fair as possible, I added a fudge factor to the Earth's rotation rate so as to get in line with the observed present value. This fudge factor was originally designed to deal with the current relative proper secular acceleration of the Earth's rotation, which is thought to result from the Earth's rounding out following the Ice Age. However, since this fudge factor is a percentage of the torque on the Earth from the Moon that actually slows the Earth's rotation, it can hence substitute for any unknown factor that reduces the slowing of the Earth's rotation without acting on the Moon. The phase angle was adjusted to 0.939 degrees, and the fudge factor was set at 91.5%. There is no known geological basis for this fudge factor. It is simply required to make the model fit reality. By making these adjustments, we once again get today's lunar distance. The projection of a number of days in a year still falls far short of the old Earth paleontological data. This model fails this critical test as well. It gets worse for this model since it starts with 729 days in a year. This is actually less than at least 2 of the old Earth paleontological data points. However, The final nail in this model's coffin is that it runs afoul of the currently accepted and presented as true theory of the moon's origin. According to this now currently accepted model, the moon resulted from an impact between the Earth and a Mars-sized planet about 4.5 billion years ago. It also has the moon forming at 1/10 the distance from the Earth as the model we have been examining. As a result, this attempt to save the 4.5 billion year figure from the laws of celestial mechanics fails every test that can be thrown at it. The giant collision hypothesis of the origin of the moon proposes that the moon formed as a result of a collision between the Earth and a Mars-sized body, referred to as Theia. This is the latest in a long line of theories, and it will be taught in schools as fact, only to be replaced in a few decades by a new theory that will be taught as fact. In fact, one evolutionist illustrated the difficulty they have in explaining the moon by purely natural means by jokingly saying that the best explanation for the moon is observational error, and that it did not really exist. As shown here, Theia forms at Earth's L5 point with the Sun and eventually drifted into an impact. The L5 point is one of 5 points between the Earth and the Sun where a small body can have a relatively stationary position with respect to the Earth and the Sun. The moon is thought to have formed after the Earth was hit by the hypothetical protoplanet Theia. The name Theia comes from Greek mythology and was the name of the Titan goddess who was the mother of the moon goddess Selene. The question before us is, can you get the current Earth-Moon system from this in a manner consistent with the observed data? What follows is an analysis of the receding of the moon and the slowing of the Earth's rotation to test the feasibility of this model with regard to the laws of celestial mechanics. These results are then compared to old Earth proponents' own paleontological data to see if they fit. This model has a set of starting conditions for the Earth-Moon system resulting from the hypothetical impact. The model has a 5-hour day on Earth when the moon formed. It further starts with the moon just 14,000 miles, 22,526 kilometers, from Earth. These starting conditions allow us to calculate this model forward to the present to see how it fits reality. The first forward calculation of this model simply involved plugging the starting conditions into the simulator with no fudge factors. It produced an initial phase angle of 6.93 degrees, which is more than twice the current value of 3 degrees. The result was a present Earth day of 44.9 hours and a lunar distance of 440,476 kilometers, both of which are significantly larger than their current value. The next forward calculation of this model plugged the starting conditions into the simulator. It forced a phase angle of 0.99 degrees and an additional fudge factor of 94.3% of the torque from the moon actually applying to slow the Earth's rotation rate. The additional factors were not based on any geological or other factors that would suggest it, but were simply what was required to get the current Earth-Moon system from the starting conditions. This simulation did produce the current Earth-Moon system, only by tweaking 2 factors of the simulation, specifically to get that result. However, the projection of the number of days in a year falls far short of old Earth proponents' own paleontological data. As a result, the giant collision hypothesis of the origin of the moon fails the reality test. Yes, if tweaked just right, you could get the current Earth-Moon system, but it does not fit other data. The giant collision hypothesis of the origin of the moon does not naturally produce the current Earth-Moon system. It only works by deliberately tweaking the phase angle and the percentage of torque from the moon that is actually applied to the slowing of the Earth's rotation rate to do so. There is no scientific basis for this tweaking other than forcing the simulation to produce the current Earth-Moon system. Furthermore, it does not fit with the paleontological data from old Earth proponents' own theoretical system of geology. Thus, this model fails. In an effort to be thorough and to give the 4.5 billion year figure every possible chance, a simulation was run specifically so as to match the paleontological data. However, the results only make matters worse for the 4.5 billion year figure because it not only fails to save the figure, but actually raises more problems for it. Here is a backwards projection for the number of days in a year as compared to the old Earth paleontological data. This fits the data, but it happens by artificially adjusting the phase angle. This is done specifically to fit this data and not based on any actual geological basis. It is done by changing the phase angle to these percentages at specific times in the simulation, as produced in this graph. Now let's take a look at the Moon's distance from the Earth. When we look at the backward projection of the Moon's distance from the Earth, it is found to be at the Roche limit about 2.067 billion years ago. This once again indicates that the Earth-Moon system cannot be 4.5 billion years old. The Moon just moves too quickly to get the current Earth-Moon system by any realistic means by starting 4.5 billion years ago. Finally, to allow it to reach the 4.5 billion years required adding an additional phase angle adjustment to 0.92% in the simulation at 1.975 billion years. The result was to reduce the phase angle to 0.06 to 0.10 degrees. Like before, this was done for no other reason than to make it reach the 4.5 billion year mark. The fact that it takes unrealistic phase angles to reach this result is enough to invalidate the 4.5 billion year figure. However, beyond 4.26 billion years ago, the phase angle becomes totally impossible since the Moon's gravity is not strong enough to pull anything the required distance that fast. Furthermore, based on the observed current value of 3 degrees, it is probably physically impossible for the Earth and its oceans to react to the Moon's gravity quickly enough for the needed phase angles of 1/10 of a degree and less. As a result, even this last-ditch effort to salvage the 4.5 billion year figure fails. The conclusion of this study on lunar recession, tides, and the age of the Earth is that there is no legitimate model of lunar recession that fits with a 4.5 billion year old Earth. The simple fact is lunar recession limits the age of the Earth to be way less than 4.5 billion years. True, it does not prove the Earth is 6,000 to 7,000 years old, but it proves beyond a reasonable doubt that it is considerably younger than 4.5 billion years. Old Earth proponents clearly understand that they have a problem here, since their ultimate response seems to be that the Earth-Moon system is too complicated to get accurate results to form such calculations. Even if that is true, this study went to every length to fit the model to data so as to get accurate results, and it still shows that the Earth-Moon system can't be 4.5 billion years old. So even in their efforts to rebut the lunar recession age limit, they only show that it is a problem for them. Now, this does not prove beyond any doubt that the Earth-Moon system can't be 4.5 billion years old. After all, you can never prove anything beyond an unreasonable doubt. However, believing that the Earth-Moon system is 4.5 billion years old requires an act of faith that there's a solution out there someplace that has yet to be discovered.